This Zoom session is being brought to you by the fractal 5x flat. Okay, today we'll be doing function composition, and 92 will be about inverse functions. Given two functions, f and g, we'll define their sum, their difference, their product, and their ratio. And you do as you might expect. It's the f plus gx on x by taking f of x plus g of x. F minus g of x is f of x minus g of x. F times g of x is f of x times g of x. And f over g of x is f of x over g of x. For this last one, we have to specify that g of x is not 0 to avoid division by 0. So, for example, f of x is 2x minus 5, g of x is x plus 1. What's f of g of 8? What's f times g at 0? Well, f of g of 8 is f of 8 plus g of 8. Plug in 8 in here and you get 11. Put 8 in here, you get 9. 11 plus 9 is 20. F times g at 0 is f of 0 times g of 0. F of 0 is a negative 5. G at 0 is 1. Negative 5 times 1 is negative 5. Here we have s of t is 3 minus s of x, excuse me, is 3 minus x. T of x is x squared minus x minus 6. What's s times z at negative 2? What's s over t at 1? Okay, s times t at negative 2 is s of negative 2 times t at negative 2. Plug in negative 2 in here and you get 5. Plug in negative 2 in here and you get 0. 5 times 0 is 0. F over t at s over t at 1 is s of 1 over t at 1. S at 1 is 2. T at 1, plug it in, you get negative 6. So 2 over negative 6 or negative 1/3. All right, here is the composition of two functions. F composed with g of x is f of g of x. So the idea is a kind of a chain of function taking. From x, you take g of that, g of x. Take f of that, that's f of g of x. And this one single swoop is f of g, f composed with g. So for example, let's f of x 2x plus 1 and g of x is x squared minus 1. What's f of g of a half? And what's g of f of a half? All right, this first one is f of g of a half. G of a half is a half squared minus 1, which is 3/4. F of 3/4 is, after a bit of calculation, 2.5. G of f of a half is g of f of a half. F of a half is 2 times a half plus 1, which is 2. G at 2 is 2 squared minus 1 is 3. Notice that f of g and g of f are not the same. This is called non-commutativity. The order of operations counts. Here's f of g of f of 2x and f of g of 2x. Well, g of f of 2x is g of twice 2x plus 1, which is g of 4x plus 1. And g of something is a square minus 1, so we square 4x plus 1 and subtract 1. And after a bit of churning, we get 16x squared plus 8x. F of g of 2x is what? Well, f of g of 2x is 2x squared minus 1. That's f of 4x squared minus 1. And f of something is twice the thing plus 1. Twice 4x minus 1 plus 1 is 8x squared minus 1. And again, not even remotely the same. Here's f of x is 3x minus 2. G of x is x squared minus x. F of g of 4 and g of f of 4. Well, f of g of 4. G of 4 is f of 4 squared plus 4. That's f of 20. F of 20 is 3 times 20 minus 2, like here. And that's 58. G of f of 4? Well, g of f of 4 is g of f of 4 is 3 times 4 minus 2, which comes out to 10. So g of 10. G of 10 will be 10 squared plus 10, like this, or 110. Now we make more generally. What's g of f of x? Well, g of f of x, well, it's g of 3x minus 2, because that's what f is. And g of that thing will be that thing squared plus itself. So 3x plus 2 squared plus 3x minus 2, excuse me. And you expand it and combine terms, 9x squared minus 9x plus 2. All right, here we have f of x is x plus 1, g of x is 2x minus 5. Prove non-commutativity. F of g of x is not g of f of x. Well, f of g of x is f of g of x, f of 2x minus 5. F of something is that thing plus 1. 2x minus 5 plus 1 comes on to 2x minus 4. G of f of x, well, g of f of x plus 1, g of x plus 1. G of a thing is twice that thing minus 5, so twice x plus 1 minus 5. After a bit of churning, 2x minus 3. These are clearly different by 1. All right. That's function composition.